All right, cool. So I'll blaze through this stuff. No, there's like a lot of deep stuff in here that that may or may not matter to some people, but it's sort of disappointing because a lot of people have said the things I'm going to say, right? And it's also kind of cool because more people are going to say the things I'm going to say. It's going to keep kind of being the same theme over and over again. But what I'm really going to be talking about is trying to get to this idea of what ARD at GG means, right? And you'll see a common theme with other people's talking and things like that. But in order for me to get to what ARD at GG may mean or may not mean, I've got to go through what DG is even working on and what we're doing and the platform we're building and how it works and how we access pixels. I can't talk right now all of a sudden. So the things I'll talk about, we have a platform called GBDX. I'll be talking about a few small components of GBDX. Raster data access is then one small component inside GBDX that is our access. What's funny about this, if you notice the acronyms, they're pretty sweet, right? ARD and RDA, it's great. We love acronyms and we love making it really confusing for people to understand everything. But analysis ready data is the last kind of thing. So ideally we have this nice trajectory where it all makes sense at the end, right? But it may be confusing in the middle, or it may still be confusing at the end, I don't know. But all right, just some introduction to DG sensors, right? We fly worldview 1, 2, 3, 4. We used to fly Iconos and QuickBird. Insanely high resolution, 30 centimeter in the panchromatic band and things like that. But what this really equates to is this 17-year digital archive, right? This massive amount of data, which a lot of us have. We have this problem. It's not like an unknown problem, but also it's about 100 petabyte inventory, right? So it's this huge processing cost. And that theme of cost keeps kind of recurring when we talk about ARD, right? But what is GBDX, right? So GBDX is our geospatial big data platform. And Jeff, you might remind me, like, what is the X in it? Like, I always thought that like GBDX meant was like Geo Big Data Exchange, maybe?
Multiple, exploit,
okay.
export.
All right. I was hoping it had like an exchange, but like no E, like X, right? But I don't know, GBDX. So GBDX is our cloud-based platform, right? It's the system that we process pixels with. We take our data and algorithms, we take other people's data and algorithms, as well as commercial data sources and things like that, and we shove it all up into the cloud and we expose it in a platform that's designed to extract location intelligence, right? It's about extracting value from the pixels. But it's doing that at high speeds and at massive scale, right? So the things we do on this platform are typically continental scale, right? It's not necessarily always been focused on understanding this small AOI over a farmer's field. It's about extracting solar panels across Australia, right? It's extracting lots of data over huge spaces. So the components that I'm really going to be talking about today are kind of the search, because I think these two planes of existence of ARD happen along finding data, retrieving data, as well as then sort of using data, right? And that's tasks and workflows, right? So the online, the platform is really a tasking framework. There's much more to it that I'm not going to really get into. So what are GBDX tasks, right? These are basically just functions, right? It's a task in any sort of web-based tasking system, right? It's a queue-based system that takes a function. Users can define their own functions. We have hundreds of functions, tasks inside the platform that define inputs and define outputs, right? These functions get grouped together in what we call workflows, which I'll get to in a second. So example functions, right? Extract buildings, extract airplanes, extract cars, extract roads, right? These are the sorts of things our users do on the platform. But then workflows take a different thing, right? So they start to wrap up these tasks into big stacks of processes. And what we really started concern ourselves with today is this concept of like raw image, right? We read the raw image, we orthorectify it, we compensate for atmosphere, and we pan sharpen it, and then we pass it through whatever other functions the user may want to do, right? Maybe it's extracting roads or buildings or doing something. But it's historically what's happened in those first four little boxes that is sort of like the history lesson of GBDX, right? It was designed around this concept of moving these large images all at once and kind of reproducing the same pixel processes over and over again, right? So we take a 1B data, we pick it up, we run through, call it AOP, orthorectify, AComp, pan sharpen. run it through that, but we do it again and again and again and again, right? And so this system became extremely redundant, and it's still used that way, but we're starting to shift it. It's moving towards more of a dynamic access pattern around data, right? But meanwhile, also, we've got this new way of creating these workflows, right? And the paradigm shifted a little bit around the concept of like, here, we're going to create a bunch of tasks for you, and you're going to know how to use the platform and come to the platform and learn it right away, rather than experimenting with something and working with it. And so this is the product that I work on, actually. It's like one of the only things so far I actually do here in this talk, right? Is Gpx Notebooks. It's basically a Jupyter Notebooks instance that allows image scientists to come to the platform and be in a familiar environment, which is a notebook environment, access little bits and pieces of imagery, right? Like, you can't do too much in a web browser on a notebook, right? But you can do enough to experiment and learn. They gain what we call platform proficiency, right? It's an onboarding tool. This is designed to allow users to come in and be efficient quickly and have that happy feeling of like, wow, I looked at some pixels and I did some NDVI, or I did something that's in the grand scheme of things wicked simple, right? But they discover imagery, and it eases algorithm development. And it eases algorithm development from the concept of you're coming in, and we have hundreds of notebooks now, right? It's only been released for a couple of months, where we've got notebooks upon notebooks of learning how to train like random forest models, right? Like, there aren't these insanely complex things, but they're learning machine learning. They're learning band indices. They're learning how to do spectral angle mapping to extract baseball fields across the state of New York, right? Really simple little things that are hard to learn unless you have a bunch of copy and pastable code in front of you. So the way that Notebooks has changed the paradigm inside the platform is that Notebooks allows users to come experiment with the analysis. They develop a function in that notebook that the actual notebook becomes the task, right? So when they deploy a notebook into GPDX, the entire notebook is the task, right? So it is one long script, basically. It's a function. And obviously not every notebook's going to fit this pattern, but because notebooks can be kind of junky sometimes, right? So we deploy it as a task, and then we run it at scale, right? And so what this allows is you to say, oh, sweet, I can look at New York City, and I can extract some buildings, or I can extract something from there, but then I can apply that same algorithm across every image that covers New York City, or across every urban area I feel like doing, as long as I can feed that workflow. But really what we want to talk about is access to pixels. So DigitalGlobe imagery is really heavy, right? These are massive strips of high resolution data. But also we have this problem of captures are not uniform, right? We don't capture on a path in a row. We capture on this like really random, just like splattering of footprints across the globe. There's no common tiling scheme to it, right? These are challenges, and they're fun challenges, but they're also pains in the ass, right? Finding the right data can be really, really challenging. This is one of the biggest usability challenges we have, is just saying, hey, I want to extract the coastline of this island, right? Obviously, we can do basic filtering. We can throw away clouds, and we can throw away things that don't fully intersect it. But when we have lots of data that intersect everything we're interested in, it's a hard problem. So these challenges kind of fall down into a couple different spheres, and I was, for lack of a better word, like technical and political. I'm a developer. I don't really deal with cost. I don't care about cost. I don't, it's like, if I can dream it, I'm going to build it, and then you're going to pay for it, right? But it's not always the case, right? And so it's almost like no problem is unbound by this cost problem. That's but I get shut down a lot on things like that. So technical, right? We have indexing, searching and finding things. The usability of the platform has been hard. But then also access to useful pixels, right? If we're working with a small little area, but yet I've got to run a task that's got to and I've got to pay to AComp and ortho an entire strip of imagery, that's absurd, right? Like, no one's going to pay for those pixels, and then again, you're going to do it over and over again. It's kind of crazy. So, but then the political, like the cost of storage of these pixels is huge. The cost of compute is huge, and then the cost of open sourcing things, like we push to open source stuff, and it's not always an easy thing to do. So here's some solutions to those, right? More direct access to pixels, right? We're thinking about, I mean, these are obvious, right? You're moving from this weird system of arcane access patterns into like, yeah, sure, more direct access, yeah. Raster tiling schemes, cloud optimized geotiff, of course. Open standards. I think open standards really foster open source. But this moves on to really the point of the talk, right? And that's this idea of the way that RDA works. This is raster data access is our access platform. And what it does is it's tiled access to imagery, but it's graph-based image processing chains, right? It's a server-side image processing framework that allows us to access pixels in a tile-based format along nodes in that graph. So an example, right? And these are really dumbed down, but we have 1Bs, right? The 1B reading of data, like the raw data storage comes from the 1B unortho rectified. We ortho it, we acomp it, we may pan sharpen it. It doesn't matter what I actually do along that chain, I can access that graph at any point along that chain, right? I don't have to produce the pixel that is pan sharpening if I don't want to, ruin my bands and pan sharpening. RDA graph, so the graph goes in, I was making a joke to myself there that I find funny, but the RDA, so those comprise the RDA graph. It goes into RDA. What RDA sort of spits out is metadata about that, right? So we use that metadata to then sort of virtually represent these massive sets of imagery in tools like Python. But here's a shot of just a totally internal tool. I probably shouldn't even be showing it, but it's not like it's sensitive. It's just not that friendly. But what's happening here is actually a pretty cool graph. And these are some of the new graphs that we're doing. Is that we're reading data at the top, and we're actually running a dynamic range adjustment, which just does some pixel thresholding, right? And then we're actually selecting out the RGB bands, and we're throwing it to what we call StreamML. And StreamML is now our new mechanism for passing pixels through machine learning models. What allows us to do is, again, just what you're seeing over here then is a slider view of both the RGB pan sharpened data next to the output of a building segmenter, right? And so we can see this actually in quote real time, right? But it's more just streaming the image out through a service that's inferring the pixels and coming back. The other cool thing that's happening inside the RDA land is this idea of templating, right? So I can take these really complex graphs that do complex operations and are tricky to construct or whatever, and serve them as a template. What that means is I have a parameterized RESTful endpoint around that template where all I have to do is pass it some parameters into the template, like the ID of the image, and I get the exact same one, right? So what this now allows us to do is think about the catalog as uniform and on demand. This virtual indexing of imagery could be enabled or could be used to enable grid-based access on some sort of tile-based scheme, right? Without us having to process the data. But so if it's latent ARD, is that ARD, right? And I think whoever the PCI gentleman who spoke said it really well. The graph or the chart he had up there, where he's showing, different use cases for different people, and it's something we need to be thinking about. And when we think about ARD, is like, does ARD just always go up to acomp and then we're done, or is it also a pan sharpened data set? Or is it actually on-demand processing of pixels that deliver it to the point, the n-1 point of where I want it, right? Because if it's not on-demand pixel processing, that's putting a lot of cost on us, right? To pre-process image. I mean, like, I'm saying these kind of like preposterously, like that's absurd. I can't like actually process and expect someone's going to want to pay for storage and access to my raw ortho data, right? My TOA data, my acomp data, and pan sharpened, which all of our users want access to all the time, right? So anyway, it's almost ARD. We have to just sort of debate internally amongst the usability of graphs. We have to look at the speed. And speed needs to increase and improve because, I mean, think about what we're doing for every pixel as we're processing it every single time that it's being delivered. Obviously, we have caching in front of there that improves it and makes it fine, but we don't have uniform spatial access yet, right? We're not looking at, or we haven't really identified or addressed the challenge of the splattering of footprints all over the globe. But what we like to call it is more latent ARD, right? It's this potential ARD in some form. I threw Gpx tools in here because I think it's really cool. I think it's worth talking about. It's a project that Pramukta and I worked on. It's easy access to pixels. It's basically the Python STK around RDA. But it uses Dask, which is this really awesome tool. It's a Python tool that allows us for deferred array access. And what we can do is we can actually virtually represent massive strips of imagery virtually and deferred, right? And then apply functions across that entire strip, and then only fetch those pixels down when we need to fetch those pixels down. And what this means is that we can take our simple Dask graphing tools or code that applies, say, a function, a simple function that does some pixel permutation on it, and allows us to take that from a remote setup to a distributed setup really, really easily, right? We can represent that graph anywhere and throw it out to the cloud or do it in a distributed way locally and things like that. It's a super flexible tool. It's really, really awesome. If you want to get into more of that, I'll talk about it. This graph's too complicated to really even talk about, but ultimately what we're saying is these virtualized chunks of data are really just saying, like, here, user, just give me a catalog ID. Like, give me an ID and a bounding box and an image, and tell me that you want it pan-sharpened and A-comped and in this projection, right? Really, really simple. Just throw it at you, and you have this massive strip of a NumPy array. Of course, they come to us really, really quickly after when they said they try to plot the strip, right? And it's like, well, no, it's like 20 gigabytes of data. You're not going to plot it that easily, right? So anyway, yeah, overall challenges, right? Speed of access is huge. Cost of pre-processing all of DHG's imagery is absurd. And then really just the usability of the archive. And so how does ARD possibly address these? I'm almost done, which is cool, because I feel like I did make up time. So defining ARD, right? So in our heads, in my head, before I attend this thing, I was kind of defining what it meant. And I'm thinking of, like, okay, pre-processed and ready to use, right, in some format. It means consistency across sensors, which is something that we've said all day long, which is really cool. But I like to call that pixel predictability, right? It's just like being able to guess it from the outside, but then also guessable access patterns, right? So there's the theme of actual pixels. Like, what does it mean to be, what does ARD mean to these pixels? But also, what does it mean to be, guessing these pixels, right? And I don't think that's necessarily just straight up stack. It's like stack's going to solve all the problems. It's that coming up with, like, an idea around, like, what formats, like what patterns of access do we use? Is it a web Mercator tiling scheme? Is it a MGRS? Is it path and row? I don't know, right? But then what is ready? What are ready images? Are they ortho, TOA? Are they all of the above? But if we start talking about tiling schemes, I mean, I'm just like laying these problems out, and they're kind of just unfolding and being like, oh my God, there's so much to talk about. Like, what are we going to do? But if we start talking about tiling schemes, web Mercator, oh, let's use this zoom level, or let's do all zoom levels, or let's do MGRS. Like, ground sample distance resolution is massive. Like, what makes sense for Sentinel and Landsat doesn't necessarily make sense for WorldView 4 or WorldView 3, right? There's huge differences in resolution issues there. Which I'm sure, like, a lot of you understand better than I do. So, cost, right? I've said this a couple times. We'll talk about it. Yay, open standards. Let's do it.
You don't do cost. Yeah,
I don't do cost. Yeah, I was like, here, skip this. Get there. Yeah. All right, thank you. That's it. Any questions? Go for it.
I got slightly lost when you started talking about graphs. Right? So the graphs basically your execution pipeline.
Yeah, a graph is a really easy thing to get confused about, right? They're super weird, right? Graphs are nodes and edges, and they can spider out in many different directions, but they're just execution patterns, right? Where, like, you can take, read this image, read that image, mosaic them together, but then split these bands out and then do like 10 things, right? You fork it out this way and do. So graphs can be really complicated. Any others?
Any other questions?
One more back there?
Maybe I'm inferring too much, but did I understand your tiled access scheme to mean there's a uniform grid that has nothing to do with the footprint of the collection?
That's what I was proposing, yeah.
Amen.
Yeah, I mean, right. I mean, because these are the things we should be talking about, right? I mean, because it's like, well, if you come from the world of, like, vector tiles or any web tiling, like mapping sort of thing, right? We have this web Mercator, ZXY, TMS, whatever you want to call it, scheme, and it makes a ton of sense for a lot of things. And so I think we just have to ask ourselves the question, is that what we're talking about when we start talking about tiled access here? But you also look at how Sentinel is stored, right, as military grid reference system. And so, like, it's it's also kind of badass and cool because it's guessable. And it's guessable in a really cool way. And but at the same time, there's also 10 others, right, that we could choose and say like, hey, it's all got to be this way. I don't know if we will, but it'd be kind of cool to, right? Any others?
One more question.
One more.
Hopefully a quick one. A lot of people keep coming back to this idea of consistency between sensors.
Sure.
When you said that, do you specifically mean with just the suite of different sensors that DigitalGlobe hosts, or are you talking about cross?
Oh yeah, I meant cross. Yeah. I mean, like, so I should have mentioned this too, but yeah. So we index all of Landsat 8 and all of Sentinel 2, as well as a ton of SAR data from MDA, RadarSat 2, and things like that. And so we index all of that and provide the same access through our graphs, right? And so obviously we don't do some of the heavy complex analysis on top of Sentinel and Landsat like we do across ours, because we have the appropriate like AOD maps and things like that for worldview. But yeah, I mean that's what I think I'm saying, right? It's like definitely across
That's an
sensors.
interesting thing people keep bringing up, and I think it's like something I wouldn't necessarily think is obvious to do at all. So, and I
Yeah.
think there might be, like, that might be an interesting thing to talk about, especially coming from a more scientific perspective, where like those bands actually do mean different things to different systems.
Yeah, no, it's disgustingly huge can of worms. I mean, it's a huge deal.
One more question, and then we'll continue.
More? Yeah.
I'm not sure of the question.
Oh.
I listened to the conversation around ARD being in the eye of the customer.
Yeah.
Just in minus 1.
Yeah, right. He said it, not me.
And well, I think that's really,
Yeah.
I'm not sure it's useful. And so in my own colleague at CCI sort of said the same thing, but
Yeah.
I think we need to boil it down to something that we can all agree to.
I agree, right. But how?
Probably assign him the concept of surface reflectance or something.
Sure. Yeah.
We might argue over what.
It's the obvious choice, right? I mean, like to go all the way to surface reflectance and say, all right, this is the thing, but like, is it though? I mean,
But if we don't get that
yeah.
first.
We just keep going around in circles.
Let's just go around in circles.
Yeah. What were you gonna say?
So, sorry for no question.
No, I like it. But that's a good one. I mean, like those kind of comments and questions are what's going to make this thing successful, right?
Yeah.
Is that like if we get together and are having those conversations, and then at the end of Wednesday, like boiling out, like all right, we think it's this, right? Or we're putting it to vote or something, right? We go.
It's worth raising that SEOS has got an analysis running data for land specification, which is basically cloud-spread surface reflectance.
Right.
There's plenty of detail in the detail, but that's the headline.
Oh, cool.
With the British.
Keith.
I'm not so sure we want to standardize on that. I think what we do want to do is standardize on a set of selectable options in your graph. I
Right.
can take these boxes and apply this and not apply that, and that way I have the flexibility in my applications.
To choose.
I understand what pre-processing I need to serve this application. For example, going to surface reflectance messes up if I'm trying to understand radiometry from an Earth albedo spectrum or something like that.
Right.
I'm just making stuff up here right now. I wouldn't want to standardize. I wouldn't want to say everything has to be surface reflectance.
Right.
We had someone talking about clouds. Well, actually, clouds are very interesting. for
Super
certain
important.
applications.
Mhm.
If you go to surface reflectance, your clouds are completely messed up now. So I'm not sure I want to stand here and say, let's take everything surface reflectance. What I really like is kind of the graph or the checkbox, and how we want to describe it as user selectable processing options.
Yeah, or what we're talking about is now different. I mean, just basically different entry points in, right? But like the stress that puts on any sort of back-end system, right? Like, sure, we've got one, we've got something, right? That can fill that. But like, could we build an open standard around DG's internal tooling? Like, probably not, right? And so, like, how do we bake that concept into a spec that says you should be able to access this along this chain of operations? It's super interesting.
Yeah.
But like two ends of the spectrum, like right there, right after each other.
No, but I think, okay, I'm going to, Steve,
Yeah.
you have one more question, and then we're going to move
I'm
on.
going to comment on that, which is saying, that's not speaking from the supplier standpoint, because I think what we would be looking to do is, you want to serve both sides, but if you're a data supplier and you're not trying to be the Earth engine or the planet system or, or an analytics engine
Yeah.
for someone, then you have to have a standard. I mean, because we can't be everything to everyone. We can't, with our systems, process everything from level 0 every time and a roll your own kind of thing.
Mhm.
It's got to be standardized. And so I think what we're looking to do is have an ARD kind of product, standardization, that works for the 90% of users. And then we'll also still offer our level 1 that is a top of atmosphere or radiance or whatever we end up having that be at, depending on actual latitude. But the bottom line is, we can't be everything to everyone. We don't want to be producing everything on the fly. We'd rather produce forward processing. We've got something sitting there that's standardized that a value-added firm or an analytics firm will understand, will be comparable to
Okay, a
what
segue.
what Lisa's doing or Fergus and what Israel is doing and anybody else. Do it at that standard. So the analytics guys have a standard that a standard base that they're processing from.
I want to close with one thought, which is I do believe you can have the cake and eat it. We should create standardized schemas that capture the options and then clamp those options into the levels we know, the level 1 and 2. But at least a standardized, there shouldn't be multiple ways to get to surface reflectance if you want it to be called interoperable, right? So one way to be very interoperable in terms of the spectral bands is to actually fly hyperspectral sensors to begin with.